goes to school 99% of the sunny days, and it is also known that 32% of all days are sunny. Construct a tree diagram to show the probability that Alicia arrives at school. So, first thing is the day can either be sunny or it can be rainy. All right, it can either be sunny or it can be rainy. So I'm going to write S for sunny and R for rainy. All right. So this is Alicia going to school. I don't even need to put that. Right. It can either be sunny or it can be rainy. The chance of it being rainy is 32%. So chances of it being rainy is 0.32. And chances of it being sunny then is 0.68. The next part of the question now, or the next part of the tree diagram is, given that it is sunny, the chance of her going to school is oh, the audio stopped. My apologies. So again, given that it is sunny, all right, given that it is sunny, chance of she going to school is, it said she go to school 99% of the time once it's sunny. So this is 0.99, and so this is 0.01. All right, so this is the chances of Alicia going to school. So I'm going to write Alicia AG. This means Alicia going to school. All right, that's AG. Chance of Alicia not going to school, AG prime, is 0.01. Now, given that it is rainy, right, what's the chance that she go to school on a rainy day? She go to school 70% of the time when it's rainy, 0.7. All right. So 70% of the time, Alicia will go to school when it is rainy, and that means 30% of the time when it rains, she don't go to school. All right. And this is the tree diagram for this. Nice and easy, soft. This takes care of part I. That's part I. Let's look at the second part of the question. The next part of the question says, what is the probability that Alicia is at school on a given day? All right, so part 2, the probability that Alicia is at school. So we want the probability that Alicia goes to school. The probability that Alicia goes to school, it is going to be equal to the probability that it is sunny and she goes to school. So it's equal to the probability that it's sunny and Alicia goes to school plus the probability of it being rainy and she goes to school. I'm using reasoning and logics and simple. My apologies. Rainy and she goes to school. All right, so the probability of it being sunny and she goes to school is, chances of it being sunny, 0.68. And she go to school, that's multiplied by 0.99. Plus the probability of it being rainy and she go to school is, chances of rainy, 0.32 times, and she go to school, 0.7. That will give you the probability of Alicia going to school on any given day. 0.68 times 0.99 plus 0.32 times 0.7, that's 0.8972. That's the probability of Alicia going to school on any given day. So since they were giving us in percentage, we can write there is a 89.72% chance Alicia goes to school. All right, so in general, there's a 89.72% chance Alicia goes to school on a given day. Whether it is raining or falling, there's a 89.72% chance that she's going to school. The next part of the question says, given that Alicia is at school today, what is the probability that it is a rainy day? Given that she's at school, so we know that she's at school. So the probability, given that Alicia is at school, what's the chance of it being rainy? So what's the chance of it being rainy given that Alicia goes to school? So that's the probability of R given that it is rainy and Alicia goes to school. Now this is a conditional probability. The third part is a conditional probability. And the conditional probability is going to be equal to the probability of R given AG is equal to the probability of R intersect AG. It's R intersect AG divided by the probability of AG. All right. Nice and easy. Now the probability of it raining and Alicia going to school is raining and going to school is 0.32 times 0.7 divided by the chance of Alicia going to school. 0.32 divided by 0.7 over 0.8972. 0.8972. Nice and easy. So you work that out, and that will be the probability of it raining and Alicia going to school. So 0.3 times 0.7 divided by 0.8972, which is 0.234. 0.234. All right, rainy, yeah. .249, sorry, mistake when I put this in the calculator, 0.249. All right, so there's roughly a 25% chance. There's a 25% chance that it is raining. There's a 25% chance in this case, all right? Nice and easy, soft. So that takes care of this question. Let's go to part B. Part B. Part B, it gives us a differential equation. It says show that y plus xy plus x squared is a solution to the differential equation dy by dx equal to y minus x squared over x times 1 plus x. So first thing, start with this. Dy by dx is equal to y minus x squared over x times 1 plus x. All right. Now, I don't like how this looks, so I'm going to separate it as two different fractions. I'm going to write it as y over x times 1 plus x minus x squared over x times 1 plus x minus x squared over 1 plus x times x. Now this looks very familiar to me. X squared over 1 plus x times x. If this is dy by dx, I can put it in this form now. And so really and truly what I have is dy by dx plus I'm going to bring it over now. I'm bringing over this part. I'm going to have dy by dx plus minus 1 over x into 1 plus x times y. That's equal to minus x squared. And then an x cancels out a x from the numerator. So it's really equal to minus x over 1 plus x. What does this resemble now? This resembles this. Dy by dx, which is y prime, plus ky equal to a function of x. And so this is a first order differential equation. This is a first order differential equation. All right. So all we need to do is to compute, find the integrating factor. So we need to find the integrating factor. Find integrating factor. So to find the integrating factor, we can call the integrating factor I. And the integrating factor I is going to be equal to, we call integrating factor I is equal to e to the integral of k dx. So it's e to the integral of 1 over x times 1 plus x. Now, how do you integrate 1 over x times 1 plus x? Well, I'm going to be quite honest, I don't know how to integrate this, but what I do know is I can integrate this by breaking this into partial fraction. All right, I don't know how to integrate that, and so I can just write down that the integral of minus 1 over x times x plus 1. I know that if I bring away the integration sign for now, separate it as partial fraction, I can write it as a over x plus b over x plus 1. Now this looks way easier to integrate, plus b over x plus 1. So I just need to find out what is a and what is b. So let me remove the integral sign for now. So finding the LCM, computing the LCM is going to be x times x plus 1. All right. X into this leaves x plus 1. So this becomes a times x plus 1 plus b times x. And that's equal to -1. This is a lot of work for 5 marks. A lot of work. So that's -1 over x times x plus 1. All right, so this is what we have. Good. Now, all we need to do now is solve for a and solve for b. You can substitute values like let x be equal to 0. If x is equal to 0, what we're going to clearly see is that x is 0, we get a is equal to -1. That's what we get for a. We let x be 0, we're getting a is -1. And if you let a become -1, and if you let x be -1, if you let x be -1, you're getting that -1 is going to be equal to, if x is -1, this becomes -1 plus 1 is 0. And so you get -1 times b is minus b, and so b equal 1. So what that means is all of this works out to just be 1 over x plus 1, 1 over x plus 1, minus 1 over x. Now I can integrate this, of course. So I can rewrite this as I is now equal to e to the integral of 1 over x plus 1 minus 1 over x. And that now works out to be equal to, this works out to be integrating 1 over x plus 1. When I'm integrating 1 over x plus 1, that's just ln the denominator. So it's e to the ln x plus 1, e to the ln x plus 1, minus integrating 1 over x is just ln x. Now, log a minus log b is equal to the log of a over b. So that becomes e to the ln x plus 1 over x. So I get e to the ln x plus 1 over x. And then what happened? E to the ln cancel each other. So this works out to be, so the integrating factor works out to be just x plus 1 over x. That's the integrating factor, x plus 1 over x. Nice and easy. Integrating factor is x plus 1 over x. Nice. Now that we get the integrating factor, we can find the general solution. So step 2, the general solution. All right, so having some freezing difficulties. All right. Okay, good. No unfreeze. All right, so continuing now. All right, so the general solution is going to be y times the integrating factor I, y times the integrating factor I, y times the integrating factor I, and that's equal to the integral of f of x times the integrating factor I. In this case, our f of x was minus x over 1 plus x. So this is equal to the integral of minus x over 1 plus x times our integrating factor I dx times the integrating factor I dx. Right. And what did we get for integrating factor? Our integrating factor was x plus 1 over x, right? Our integrating factor was x plus 1 over x. That's our integrating factor I. And so what we get now is y times x plus 1 over x, y times x plus 1 over x, that is equal to the integral of minus x over 1 plus x times x plus 1 over x. They have minus x over 1 plus x. No, this is a lot of work for 5 marks. This is a lot of work. So it's minus x over 1 plus x multiplied by integrating factor, and integrating factor is x plus 1 over x. Stop freezing. All right. As you can see, this x cancels this x. This 1 plus x cancels this x plus 1. And so we're just left back with integrating minus 1 dx. And the integral of minus 1 is just, the integral of minus 1 is minus x. So this works out to be minus x. And remember, when you integrate, you get plus your constant of integration plus c. And so if you were to expand in y on this side, y times x is just x times y plus y times 1 is y all over x. If you multiply this equation through by x, if we multiply through by x, what are we going to get? If we multiply through by x, what we're going to get is, multiply through by x, we get xy you get xy plus y is equal to x times minus x, that is now minus x squared, plus c, all right, plus c. Now we're finished now, we're done. All you need to do is bring over the x squared to the other side. And if you bring over the x squared to the other side, what you're gonna realize is, we bring over x squared to the other side, we're gonna get that this becomes y plus xy plus x squared, y plus xy plus x squared is equal to c. Y plus xy plus x squared is equal to c. All right. Now let c equal 0. Just give c the value of 0. Let your constant be 0. Let c be equal to 0. And if c is 0, clearly we're going to see that we get the solution y plus xy plus x squared is indeed equal to 0, a solution to this differential to it. It's a solution to the differential equation. So hence, it is indeed a solution to the differential equation. Nice and easy, soft. No issues whatsoever. It is indeed a solution to the differential equation. Nice. All right, we're good. We're good, good. Now let's look at the next part of the question. The second part of the question says, a differential equation is given by y double prime. So you have y double prime minus 2y is equal to 0. It says find the general solution. To find the general solution, we first solve the auxiliary equation. The auxiliary equation would be, u squared minus 2 is equal to 0. Solving u squared minus 2 equal to 0, we can factorize it to get u minus root 2, u minus root 2 times u plus root 2 is equal to 0. So u minus root 2 times u plus root 2, you get that that's equal to 0. And so what we end up getting is solving this equation equal to 0. That implies that we're getting u is equal to root 2, or u is equal to minus root 2. And so, because it have unique roots, it have two different roots, then the general solution, which will give us our complementary function, I like to call it yc. Yc is equal to p e to the root 2, pe to the root 2x plus q plus q e to the minus root 2x. All right, that is our minus root 2x. It should be 2 minus root 2x. All right, so that's the general solution. So that takes care of part I. Nice. Now let's look at the next part of the question. It says, hence, show that the solution would satisfy the boundary conditions. It says that y naught is equal to 1 and y prime of root 2 over 2 equal to 0. Hence, show that the solution satisfies the boundary conditions. So what that means is, if this is so, pretty much what we're doing is solving for P and Q. It is giving us that Let's start with the first one. It says y of 0 is equal to 1. What does that mean? If y of 0 is equal to 1, then that implies that when you put x as 0, y is 1. So that implies 1 is equal to p times e to the root 2 times 0 is 0. So this is just p times e to the 0 plus q times e to the 0 and 0 q to the 0. And so the first equation that we're getting, I can put it in bold right here. The first equation is 1 is equal to p plus q. So write down this equation. 1 is equal to p plus q. We're going to get another equation now. The other equation that we're going to get, it comes from differentiating yc. So let's write this down. It says, we know that yc, meaning the complementary function, is p e to the root 2x plus qe to the minus root 2x This is what we know. All right, and it says y prime. So we need to find y prime. So to find y prime, all we need to do is differentiate this. So to get y prime, we're going to differentiate it. When you differentiate this now, you're going to get the derivative is equal to, how do you differentiate e to the root x? Differentiating that, you're going to get root 2p. You're getting root 2p, root 2p. So you're getting root 2p e to the root 2x. All right, and then you're getting plus, well, when you differentiate this part, you're going to get minus root 2q. So you're getting minus root 2q minus root 2q e to the minus root 2x. E to the minus root 2x. All right, so what does that mean? So that means that since this is yc prime, and then remember they had given you this equation, they had told you that y prime of root 2 over 2, they said that y prime of root 2 over 2 is 0. So that means when you put in, x as root 2 over 2, y is going to be 0. So let's do that substitution now. When you put in y as 0, that's going to be 0 is equal to root 2p times e to the root 2x times root 2. Now root 2 times root 2 is 2, 2 over 2 is 1. I'm going to get times p e to the 1 minus root 2q e to the minus, now root 2 times root 2 over 2, root 2 times root 2 over 2, that part give you minus 1. This part give you e to the minus 1. So from this equation, we're getting that root 2, we can divide through by, well, don't divide through by e yet. What we're getting is, I'm going to bring this part over here. So I'm getting root 2q, I'm getting root 2q over e is equal to root 2p times e. All right, that's what I'm getting. So clearly, these root 2 going to cancel each other. So this root 2 cancels this root 2. And so the equation that I'm left back with is Q over E is equal to P times E. All right? So Q over E is equal to P times E. Right? So if I cross multiply, I'm getting that Q is equal to P times E square. Q is equal to P times E square. So we're going to keep a note of these two equations, all right? Q is equal to P times E square. And remember, P plus Q equal 1. So we have a simultaneous equation. So let's solve it, man. So P plus Q equal 1. P plus Q equal 1. And Q is equal to, I think, P E square. All right, so all you need to do is, since you have Q right here, you can substitute for P. Q is equal to 1 minus P, and so that means 1 minus P is equal to P times, you don't need to even do that one. Let's substitute Q as PE square in the first equation. Substitute for Q in the first equation, so you're going to get P plus Q is PE square. P plus PE square is equal to 1. How can I solve for P now? Since both of these have P, I'll factor out P, and I'll get P into 1 plus E square. 1 plus E square, that's equal to 1. And so I divide through by that now. And so P is equal to 1 over 1 plus E square. That is P, 1 over 1 plus E square. Since this is P, remember Q is P times E square. And so Q is going to be P times E square, and that will be E square over 1 plus E square. That's going to be Q. All right. So Q is equal to E square over 1 plus E square. Nice. Thank you. Finally, we find P and Q. So good. So now we're just going to go back to the general solution. Remember, we said that YC was P times E to the root 2x. This was YC, P times E to the root 2x plus Q times D to the minus root 2x. Remember, we said that was that minus root 2x. Yeah, man. Now we're just going to replace with P and Q. And so in reality, YC is just equal to P is, let me fix that up. P is 1 over 1 plus E square, 1 over 1 plus E square times E to the root 2x. And then Q is going to be plus Q. Remember, Q is E square. Q is E square, but when the bases are the same, you can add the powers. So you get E to the 2 minus root 2x over 1 plus E square. And that is it. Nice and easy, soft. Of course, we didn't write it in the form that they wanted. They wanted us to factor out 1 plus 1 over E square. So we can factor out 1 over 1 plus E square. We're going to factor that out. And so we're going to be left back with E root 2x. So left back with E root 2x plus E to the 2 minus root 2x. Nice and easy, soft. So as we all can see, this was such an easy question. Easy does it, soft. And so that is shown. All right, so shown. All right, soft. All All right, that was an easy question. Nice. All right. Nice. Well, as you can see, I mixed up the questions. This was actually question 6. So we actually did question 6 and we didn't do question 5. So now we're going to go back to question 5. So I totally skipped over question. I skipped over question 5 and did question 6. That was question 6. So all of this is question 6. All right, let's go to question 5 then. My apologies, not doing it